Right now, there's only 4 modes of transport. We have trains, we have planes, we have cars, we have boats. And that's a really small number, 4. So the opportunity to work on a 5th fundamental mode of transport is a really rare and special thing. It's probably the first time in history that an event like this has happened, where a group of students were all gathered under one roof to possibly lay the foundation for a new mode of transport.
Hyperloop is a new form of transportation that was proposed by Elon Musk, who is the founder of SpaceX and the CEO of Tesla Motors. It will allow people to transport at insane speeds at 700 miles an hour.
Imagine the prospect of living in Cincinnati and working in Chicago. You can be living in Boston, you can go grab dinner in New York City and be back the same day in Boston. How cool would that be?
When you connect major cities in a matter of minutes, the flow of information, the flow of people, the flow of all the possible goods and services that can happen between the cities, the possibilities are endless. When the Wright brothers, not too far from here, came up with the idea of an aeroplane, it brought humanity from a paradigm to a new one, which they never thought would happen. So a new transportation system like the Hyperloop would do the same, would bring humanity to a new paradigm.
Elon released the Hyperloop Alpha paper, which I'm sure everyone has read very carefully in this audience. And his whole goal was the 5th mode of transport. So the opportunity to work on a 5th fundamental mode of transport is a really rare and special thing. That's the purpose of this competition.
My name is Dhaval Shiani, and I'm the founder and team captain for the Hyperloop UC team. I want to be the one who constantly changes focus and changes his perceptions on whatever is going on in the world. When SpaceX announced the competition, we sprung to action and started gathering a team. So I was looking for people who are good at marketing, who are good at business, and who are good at design and engineering.
My name is Sid Tatham. I am the business lead of the Hyperloop team and a graduate student here at the University of Cincinnati. Elon is from South Africa originally, and he came to the US as an international student. I'm an international student, and it just amazed me how an international student could do so much regardless of where he came from, and that kind of drew me towards the project. A lot of my work goes back and forth between finding people on campus who would support the project.
My name is Shaban Abdallah. I'm professor of aerospace engineering. I am the Hyperloop supervisor.
I had known Dr. Abdullah from my previous work on some of the research projects that we had done.
So they came to me and asked me if I would accept being their academic advisor. I said yes.
Recruitment at the very beginning was kind of like a startup sort of a thing. Students were talking among themselves with their friends.
The first time I heard was on a Facebook post.
The thought of designing the whole system, working with all new components, was pretty exciting. That's what inspires me. We'll be designing something new. Like that one statement was the thing that got me into electronics.
There came a point wherein we had to recruit people to work on the non-engineering side of it, and they said, hey, it's interesting, how much would you pay us? And I'm like, well, about that, there's no pay, it's just a student group.
I did not hesitate a moment. I just wanted to be in the team.
I had actually seen a Hyperloop UC application on Facebook, and I was like, oh, this sounds cool.
College of Business folks were on the team, e-media folks were on the team, and of course engineering. So the focus was to get as many people on board as possible, but we were very conscious about getting a diverse team, because something as big as this needs as much diverse perspective as you can get.
The competition was divided into 3 stages.
In this phase, we are trying to put up a lot of our designs into the competition so that it's easier for us to explain it to SpaceX what we are trying to do.
People's first reaction when they hear about Hyperloop is they get kind of scared. Like, they don't want to go through a tube at 750 miles an hour. They just don't think it's going to be safe. But once we get to explain it a little bit more and give them some detail, then they kind of understand, like, wow, this is something that's like really cool. This could revolutionize the way we live every day.
Right now, people see it as something that just seems like it'll always stay in science fiction. But the way to counter that is by showing them something that they can relate to. My name is Julian Gregory, and I'm an industrial designer on the Hyperloop UC team. I would think about how humans would get into the pod and what would their commute be like. People are in this tiny pod and it's traveling 700 plus miles per hour and there's no windows. How do people feel comfortable in that space? My original concept was this idea of floating comfort. Say they arrive to the Hyperloop station, their phone has their seating arrangement on it and how they like their chair recline and how they like the temperature of their chair to be. What Hyperloop UC is doing is something that has never been done before. It's a concept that was on paper just 5 years ago. Now we're actually building and testing what could be the next method of transportation.
Can you believe we are here? There are over 1,000 of students registered representing 20 countries, over 100 universities.
When we got the email that we were going to be invited to go to the Texas design presentation, we were all pretty excited. It was something that we had been working on for months.
The whole experience was pretty exciting to see universities from different parts of the world.
We realized that it was going to be a much bigger thing than we had anticipated. The people that were showing up to the event were people that we had never thought we'd ever get a chance to meet. People like Rob Lloyd, who was CEO of Hyperloop One. There was a Secretary of Transportation, Anthony Fox, at the event. And then obviously there was Elon Musk. Elon was in a gathering of 1,000 hardcore engineers who are crazy fans of his. All of these people, just to get a chance to speak with them was something that dreams are made of. This event had one session for a public where anyone from the general public was allowed in, and they would come in and talk to you about what the Hyperloop is.
At that point, it was more about being able to network, being able to build relationships outside of UC, and making sure that as many people as possible knew that there was a team from UC that was there.
People related to SpaceX, Tesla, would come by your booths, have a chat about what your design was. On a simultaneous front, you would have judging panels. So we had two separate compartments. The first one would be an engine compartment, and the rear one would be a passenger compartment. So in case of any anomaly, you can just remove the passenger module and leave the engine module intact. We thought that our design was very scalable and modular. We were very proud of that. When we saw the other designs at Texas, a lot of people had focused on designing for the event. That was the part that we were happy with not doing, but there were a few teams that were head and shoulders above the others, who had pretty neat ideas, and they had kind of packed it all tightly together, which was something that we needed to do. That was kind of a wake-up call for us, and we thought, okay, we need to step up our game if we want to compete against the likes of the teams that we've seen here.
When I call out your name, that means you are in to go ahead and move toward competition weekend.
The final results were being announced on in front of a stage, and only the team captains were allowed to be in that area. All of the other folks were standing behind the stage.
The first team going through, U Waterloop Hyperloop, University of Waterloo. U Washington Hyperloop, University of Washington. University of Toronto.
It was a nerve-wracking time. My heartbeats were off the charts.
RUMD Loop, University of Maryland and Rutgers. Gator Loop, University of Florida.
And I believe around 11 names had already been announced.
We're almost halfway there. Our next team, Hyperloop UC, University of Cincinnati.
We were excited.
We were jumping, it was all ecstatic.
When the name was being announced, I have no idea what happened. I could just hear some hooting and hollering.
It was good that the hard work we had put in, it was finally giving us some results.
Our names have been announced, and there's a lot of work that lies ahead of us in terms of the money that we have to raise, and hell, in terms of physically getting this thing together. Sure, it's on paper and people have approved it, but we have to physically make this thing and put it together.
We came back from Texas. We took a couple of days off. Then we met again.
To build the pod, that was like a big challenge.
It was a nightmare. There was a lot of doubt as to if we can build the pod, and there's nothing much we can do if we don't have the money.
My role with the Hyperloop team is with the financing, fundraising, and marketing. A lot of what I'm doing is just kind of helping with the social media, how we reach out to companies, how we reach out to the community.
I actually didn't know how much we needed to raise. You know, they just kept on saying, hey, can you send out more sponsorship letters? Hey, can you do that? It's easy to send out a sponsorship letter and say, hey, you know, give us money. But building a relationship's much harder.
The companies that I contact, they really range. They could be anything from like restaurants to technical companies. So we could just be looking for a strict sponsorship where we might just get cash donations, or it could be a technical company where we'll be looking for testing time or materials and in-kind donations.
Between the design weekend in the beginning of 2016 in Texas and then the actual competition, we had to raise quite a bit of money, $200,000.
The most difficult part of the process was the fact that a lot of people did not know about Hyperloop. While there was a lot of support, the support was eventual.
It's very difficult, especially for fundraising, because you're going out to these companies and asking for either in-kind or monetary sponsorship for something that really doesn't exist yet.
A lot of people that we approached off campus said, hey, you know what, sounds like a cool project, but this is not something that we would support at this point right now. And a lot of people didn't even respond. There were a lot of times when I as an individual was nervous, but we had a long conversation about the money and how much money we needed at that time. But more important than that was the space. And there was no space on campus at that time, to our knowledge, that we could house a pod that was almost 16 feet long. Dean Lim was pretty kind enough to let us borrow his lab. The student level organizations, they were all pretty supportive. Provost was supportive, the graduate school backed us, UC's Research Institute backed us.
For the first couple of months, we were experimenting with electronics, we were experimenting with hardware, and also with the materials that would go on the pod. And the structures and other teams started building the brackets.
In addition to just the money, we need a lot of technical help. Since we are all student engineers, we don't have a lot of experience building stuff. Two of the biggest supporters were Tri-State Fabricators and Cincinnati Incorporated. Tri-State did all of the welding job that went on the pod. They built the frame for us, and Cincinnati Incorporated basically machined every bracket that you can see on the pod. The people who made the carbon fiber skin for us is a small company called JMS Composites in Springfield, Ohio.
We were going for an active levitation mechanism that was the hoverboards. And for that, we needed a huge battery system. So initially, we had 48 batteries on our pod, and that's what we started designing with.
We wanted to showcase what we had come up with to the world. A lot of the things that we had put on the pod were novel and exciting, like the static hover system that we had for levitation. That was something that I had not seen anywhere in the world. It sounds like something out of sci-fi, basically like engines taking off and landing. People seemed very excited and curious at that point. I just wanted it to work.
Being one of the first teams to achieve static levitation, it was like just kind of an awesome feeling.
No one else in the world had made static levitation technology for the Hyperloop work at that point. Not even the companies that were working on it full time. That told us that we were doing something that is truly on the edge of innovation and on the edge of pushing the boundaries. In general, life has been pretty busy, not just for me, for everyone on the project. Everyone has coursework, everyone has research requirements, and most of us work part-time too. That kind of juggling act between the three things that we have to do makes things difficult for a while. So when we have to assemble the pod, it's pretty much straight all-nighter session, and we would work in like groups.
At first I was like, I don't know if it's ever gonna happen. But then there are so many things in life which you don't think that they will happen.
We've put so much work into it, so it's very exciting, inspiring just to see what we've done.
We were pretty confident, and with that we went to California for the final competition.
It was very interesting experience when we went to California.
There were like mixed feelings, excitement, nervousness.
We had seen SpaceX on TV, we've heard about it, we've seen videos on YouTube, but to be at the SpaceX facility was pretty exciting for us.
So this is what the future looks like. And it is rare in our lives we get to feel that moment. Our problems aren't new as human beings, but the ways that we're approaching them are. Today here at SpaceX and with Hyperloop, we are the capital of innovation.
We've got 800 students, 27 teams, some of the smartest engineering students in the world. Thank you for coming. Congrats to everyone. I'm amazed at what the student teams have done. Really it's blown my mind, and may the best team win.
It's Friday at 3 p.m., first day of the competition. Students are pretty excited about being here, actually being here at the SpaceX facility.
Initial 2 days were just assembling the pod, and everything was working fine.
When we got a chance to see what the others had done.
The things that sets us apart are two things, I think. First of all, our levitation and stability system is completely passive. And then secondly, we have a capsule on top.
What we have here is a micropod, which is a smaller version of what everybody else is doing. We want to build it as compact as possible. They can fit in the luggage, and then we can bring it to America with us through airline. This is the rare chance for us to reinvent the new mode of transportation system in this century. We could be the Wright brothers in this moment.
I think something unique about our pod is our frame. We kind of went with an old school airplane wing box design that it uses very little power to actually operate.
We have a compressor, which is, I think we're one of 2 teams with a compressor on board. The team's feeling pretty good right now, and SpaceX just let us know that we will most likely be able to get on the big test track either tonight or tomorrow.
There was a huge, around 98-point checklist that every team had to pass through before they were allowed into the final run, and we just got going at knocking off stuff from that checklist.
Before going to SpaceX, we didn't anticipate any problems. There were many things that we tested a lot, and there were many things that we didn't test much. The problems started coming in actuators.
We realized that the actuator wouldn't retract.
They generated a lot of current because you're restricting them, and the current, it will want to come out. And then it goes where? It goes to the electronics, which is connected to the actuator, and it fries them.
Out of 8 motor controllers, we blew up 6 motor controllers. So we were just left with 2.
I was in shock when we ran into complications at the competition. We were in desperate need to come up with a solution, or maybe come up with a new motor controller, or like design a circuit that would actually prevent the current from going to our electronics and frying them again and again. Those 2-3 days were very stressful, and we wanted to just get it working somehow. My anxiety levels were peak high. I was not sleeping, not eating.
Since it was a very specific application, we tried to troubleshoot it as much as we could.
The braking system is actually divided into 2 parts. One is the magnetic braking system, and one is the friction braking system. And they require different types of brake pads and equipment. When our magnetic actuators failed that time, we had our friction actuators to actually let us continue in the competition.
By the time we decided of just going into the run with the friction actuators, many teams had already cleared majority of the tests.
And we did the vacuum test, and it was all fine. Everything seemed to work well.
Everything went well with the vacuum testing. I'm happy that our team got those things working even in that amount of time, but then it was too late for us. It was sad.
We couldn't beat the clock. We couldn't get ahead of schedule. You know, every single time a SpaceX representative would come by, we either weren't ready or we're still having difficulties.
It was too late. Like, we couldn't get on the external subtrack, because if we can't get on the external subtrack, we can't do the open air run, and then we can't do the vacuum run. Being at SpaceX, working for such a long time on something so huge, it was very depressing for us.
It was a sad time for us.
We just simply ran out of time to do the one test that we had to do before we were allowed into the tube. It was an electrical component, it's an engineering challenge, and things don't work well the first time. Even if you see the Apollo projects, not that I'm comparing this to the Apollo projects, but I'm just saying that if those guys can mess up, I'm pretty sure student engineers can too.
The judges were super impressed by the variety of teams, international. The sizes of the teams range from 4 to 60. One of my personal favorites is Kyu from Japan, who sized their pod such that they could fit it in their luggage in order to get into the United States. The trophies we have here, one are autographed by Elon. The team with the highest score. Remember the summary of the sum of all of the other categories, and that's Delft.
Giving up was never an option.
Everyone wanted to work, and everyone wanted to make a better system. Everyone wanted to work on the flaws that were there.
The best thing is to correct and move on.
I have learned so many new things in electronics components. I really look forward to continue working on this.
It's so humbling, and it's good to see that so many people are working at the project, and we are all working towards one goal and trying to make it happen.
Moving forward, we're not sure where it's going to go, but it's absolutely going to change the way people will travel, and it's going to change the way people live. The work that Hyperloop UC has done is going to be putting science to good use.
There are huge industries around Cincinnati. This can be a very good opportunity for Hyperloop and for Cincinnati to actually come together and do something good.
The most rewarding part of the project would be the learning experience. We as students have had a chance to work on something as real as this. It does not get any more real than Hyperloop UC.
Those are the valuable lessons that I think will stay with the team for the rest of their lives.
We as humankind, if we're not applying what we're learning, what we studied, what we observed to good use, the whole process was, that was for nothing.
When Hyperloop as a concept was introduced, it was science fiction. And now that we have started working on it, developing technology and experimenting and proving that this works, it's science.